show simple examples like linear regression and things like that, and do some machine learning in Haskell, which in itself is quite interesting. But sorry, not today. It's like you could have something really cool, but not today. Yeah. Right, we're here, and type level program. Yeah, sort of. I don't think it's that bad. I think it's within it. It is. You can barely program in value level. Man, I doubt that. You seem to answer a lot of questions, and you've been getting on fine, I reckon. One of the worst things, definitely with Haskell, is you always feel like you're crap until you get good, and then you've forgotten how you got there. Yeah, I'm still feeling crap. Don't worry. It's just natural, I think. Where do we get to? So look, so we did some of this. I've got to try and remember. So here we go. We did some bool. Yeah, I'm glad you agree. Hold on, let's shift this over. So then we're seeing both at the same time, and then we can sort of get rid of that. Let's have a look. So we did H-lists. We did some sort of like lists with this, which looks like to be a little bit further down. I can't remember if we'd stopped at constraints. Looks like, yeah. So did we do 5? Oh no, it feels like it's a little bit further on than this. It's chapter 4, chapter 5. Chapter 5 is definitely chapter 5. What else would it be? It wouldn't be chapter 10. I don't know why we haven't got this up here, so that's why I'm just wondering. Oh, we do. Further up. Okay. Get on. Keep going. So we obviously started some GADTs, didn't we? I think you did the GADTs part already. Good spot, Leo. Right, carry on. So it looks like we've got expression here. We've done this stuff, which is that. Yep, keep going. Some H0. Right. It looks right around here, doesn't it? I think I bailed before exercises came in. I think that's what happened. That feels like the sort of thing I'd do. I'm not looking... There's some other exercises further down the line, which I should have probably learned before I did them. Was like do some sort of an instance for a monad transformer. So that might be... I probably won't get that done today. I'll probably bail out quickly before as well. So we've done H-length, we've done show bool. Yeah, we have. Cool. So we're literally, it looks like we're onto this bit, aren't we? Let me know. I think that's like big enough. I can zoom it in actually. Let me try that. Zoom in. Oh, yeah, but then it mucks it all up, doesn't it? I wish it was a half zoom. That'd be perfect. There isn't. So, works for you. Cool. I'll go with that then. If that's the case then, we can bring that down a bit to match. So unfortunately GHG stock deriving machinery doesn't play with nicely. Yeah, so we got, do we get a fault when we did this, or I can't remember. Anyway, I'll read it. It will refuse to write EQ show of other instances. Oh, okay, so if you want to say, do we have a H list somewhere? Yes, we've got it here. Here it is. And it's not, it can't write EQs or shows. So you can't derive them, you know, like if you have normally, well, not just in data types, you can just do deriving. Whoops. Oh my goodness. Yeah, you can do something like that, and then an example you'd probably see would be show an EQ, and then it would derive it for you. But we can't do that, so I think that's what it's saying. So we have to make our own instance, which we can do. So we can have, this is going to show you one way to do it, and then it's going to show you another way to do it, in essence. But we'll talk through it. Actually, I'm copying the wrong thing. No, I'm not. Yeah, I was. I'm jumping the boat a little bit. Jumping the boat. I guess that's the word, isn't it? So we can go EQ. It's H. Is it going to find it? Do we have a... No, we just called it H, so it's fine. And then we can do that tick, which I've totally forgot what it means. Well, I know what it means, but I've totally forgotten the name of it. It's is it raised something, or I don't know. That's why I'm not academic. I'm just terrible at remembering. I totally understand its meaning and where it comes from, but its name catches me. True, someone will remember. Maybe. Okay, so it seems happy with that. Yeah, let's have a look. I'll just... whoa, look at that. Definitely didn't want to do that, did we? That was an unexpected behaviour. Oh. Okay, we'll do it again then. Wow. What I'll do actually, because this is really whinging at me. I wish it wouldn't slow down so badly. Right. I'm going to just minimise that. Hoping. Okay, that's cool. So that's what we've got. So we want a flexible instance, which I think will tell us. No, we'll just add it anyway. Okay, it's happy. But you can write your own by providing a base case for HNIL and an inductive case. The base case is that two empty H lists are always equal. So we've just shown that. Two empty H lists, well, there's HNIL, so that's one of our, and then the cons is the other one. So they're always equal, and then the other one we can write is instance, where was it? Yeah, EQ or H list, H loist, H lost, H lost, H loist, H list. We'll get there. Except I've totally copied what I was doing. Oh my goodness. Yeah, I need to. I wonder if like a more powerful computer would sort of. I don't think so, because this is like, it's pretty high spec, this computer or laptop, but it still seems to struggle. Oh well. Yes, we've got that. I'll explain this in a moment, what's going on. Let me just type it out. We'll work it out together. And T, and then this is the cons. It goes like that, and TS. That looks about right. Yes. Okay. Where and right. So what we're doing constraints are. So clearly this one is for nil. So the only thing we want to, you know, when you do what you do with HList, you have to do it in two, which is a bit weird. So the first one is because we're dealing with the, you know, the nil. So like the empty case, I guess, of there. Yep. And then now we need to sort of deal with the rest of the list. We need to sort of work out some equality to that. And the problem being is obviously there's going to be some form of recursion going on. And that's why you need to do an EQ of the T, which is like the head. So you can see how there's a type constraint here on the left. So there's an EQ of T, and then there's a, it shouldn't be a dot, it should be a comma. Wow. That was like, why is there a dot there? Yeah. And then the EQ to the H list of TS, so that's like the rest of the list. Because we know that T is going to be just the value inside, and then the TS is going to be the rest of the list. So it's going to be like this part. Boop. It's not even going to be cons. It's just going to be like that with a value inside. Okay, so that's what we're doing. A constraints there to handle that. And if you see, the one above just doesn't have that, and instead of having empty, we've got actual some information inside. So that's cool. And then from there, we can destructure these out. So we're using the terminology for the cons that we've created, which is like a colon hash. So we've got the head and the rest of the list, and then it is equal to the head at oh god, and the rest of the B's of the list in B's. Okay, so that equals A is equal to B, and then we're going to like just like that. Okay. Yeah. So ultimately what's going to happen is going to check these two, and it's going to keep going. So the A's and B's will just keep going round and round and round and round until it gets to the end, and then it will hit this one, that, and then that will return true, and then it will have to check that they're all true to be true. Otherwise, if one of them is false, then it's false. Cool. So now we've got to do the same deal, but we have to implement our own ORD. Which there was from memory. I thought there was an example further up somewhere. Maybe there wasn't. Okay, well we can just do it. So now we can do an instance of ORD. Yep, and we'll do the empty. Let's make some. we'll do some of that, and then we'll do some of what's this one? EQ. It's one of them, isn't it? Not having it. My keys won't work. Not my keys, my brain. Okay, so we've got ORD, and now we need to do ORD for HList. Empty ORD, do we need to do? I can't remember, to be honest. I'd assume so. Where? So normally it's meant to... I can't actually... ORD, what... what's the function on ORD? Let's have a look. I've forgotten. So this is how we're going to look it up. I'm going to go ORD. Type class ORD, there we go. And then we'll get to see what's on it. ORD. ORD. Which one? So we just want to do compare. There we go. That's all we want to do. So I thought it was going to give it to us. Maybe we do. Here, hold on. Normally this is meant to give us a hint as to what's missing. It'll go, hey, you've got no something for something missing. There we go. An explicit implementation for compare. That's what I could have just, or that one. Okay, we'll just do compare, won't we? So we can do compare. Would it be just HNIL? Or do we do all in one? I'm assuming it'd be... I'm assuming you want to do it as two things. So one and then the second. And that would be EQ. Yeah, there we go. That makes sense. So if we look at ORD... yes, so there's your typeset returns. I don't know why it doesn't show it there. Yeah, but anyway, so you got less than, greater, or LT... GT, EQ, so less than, greater than, EQ. So that makes sense, doesn't it? So we can do the nil case, because two nils are always going to be equal. And then we're going to have to make up this sort of case. We can literally, we'll copy that. And then we'll want, I guess that'll be ORD. This will be ORD. Yes. And this will be ORD. Yes, and then it will say no explicit for, what is it, compare. Yeah, that makes sense. So now we want to do it for the rest of the list. So we'll do exactly the same. We'll grab this stuff here. Except we want to do compare, just, here we go, yeah. I'm going to do like that. Oh, this, I haven't really got a clue. So look, so we want to return, found a hole, so we just need to return an ordering. So we need to do, oh, I know what we need to do. Surely it's going to be something like compare A, B, and again compare A's and B's? What do you reckon? No. Oh, because it's bool. So it's going to be... Okay, maybe it's like this then. Yeah. Wow, I got it. Wasn't expecting that. But that makes sense. Because we're wanting to sort of compare everything. And what it returns. So here, because you can do this. This is ultimately... Control C, Control R. There we go. We'll just go inside the REPL. We can do this when it comes in. No, I don't want to change it. No, I don't want to change it. Here we go. So let's do compare. Yes. We can do greater than, less than. There you go. So you can compare the result, the return types or the constructors of ORD. So that's what we're getting. So if you think about it, when we compare A and B, whatever that might be, so that might return you a greater than. And then here it's going to recurse over the results. So that'd be like a bunch of these recurse, and then that will return one value. And then you return, at the end, you're comparing whatever that is, and then that'll return you. But obviously if you do compare, if they're both greater than, then it's EQ. Yep, so that's not too bad. And then we'll do an instance for show. I think was the next one. And let's just copy it. It'll be totally different, but, well, not totally, it won't be far off. Show, and then we've just got show h-nil. So this one should be pretty damn easy. And it'll be just yeah, that's fine, which makes sense, doesn't it? This one will just be a little bit more in depth. Will it be a bit more in depth? Probably not, actually. We'll change that. We'll change this one. This one, yeah, so we've got all the stuff. Here we want to show, oh, I don't, so we, oh, yeah, that's fine, A's and like that. And then now we want to return some strings. So I think here would be show A, and then to sort of, yeah, because we want to return exactly like its representation, so I guess it'd be like this. A bit of the, should we do some like that? Yeah, there we go. I don't know what would happen here though. Okay, seems happy. I'm gonna restart my fire. Your love is my only desire. Okay, it's happy. I'm fairly sure that's correct. Does it? I can't remember if it actually gives you the answers. I don't want that one. Where am I? I'm gonna go back to this one. Well, we've definitely created a show. So look, where do I have it? I can cheat. Well, it's not technically cheating. We've done it and it works. But there it is. Source. Chapter 5. Chapter 5. So look, what does it do? Show A's. Yeah, cool. So that's right. Thank you. We'll have that. And we'll say goodbye to you. Okay, so that makes sense. We're doing exactly the same business. We're doing a... Oh, go away a second. Like that. So we're just doing a show instance for HList. I want to... Is it erased something? I want to remember what that's called. Should we go look? I feel like I need to go look. What page are we on? 70. Okay, so where does it introduce it? It's not in GADTs. I think it's before, isn't it? Yeah, it's certainly before. I'm going to find what you called. What's this one? Working with types. Where does it introduce it? Maybe it's even before that. Maybe it's right near the beginning. No. It's when we... I think we did it with there. Yeah, but it's got a certain name when it's got a tick in front of it, like here. You see that one? Maybe it's further up. There's a name for it and I'm trying to remember it. So it's not type scoping, type application. Maybe it's a bit further. It's when they're both in scope. It's not variance. Oh, here we go. It's around here. Right. Because this is maybe it's introduced a little bit further up then. Closed. No. There. It's, level ones we can instead promote. They're called something promoted. I said raised. No. Type level. It doesn't give it to us right here. Maybe it's a bit further up then. Fine. Where is it? Come on. Computer, stop buzzing. That is of kind. What are you called though? Oh. We're not going to find it. Wish I had a better memory. Then I would have just remembered it. We've gone too far now. No. No. Here we go. It's one of these. Drew. Promoted data constructors. Right. I mean, I'm way too... But what I'm going to... that was pointless, wasn't it? But whatever. Promoted data constructors. Let's go in here. What chapter is that on? 2. Let's go in here and let's... Where are they? These. Promoted data constructors. Yeah. But you were right. It is a type level list. Right. Okay. So we've done this stuff. We'll go back to page 70. 39. 59. 63. 69. 70. There we go. Cool. So we did that. So the reason we had to write 2 instances for EQ was to assert that every element in a list also had an EQ instance. Yeah, so we had to like... Because I've tried putting them together and you just can't do it. Because you end up not being able to deal with the HNIL, which is weird. I don't know why. It doesn't explain why. It just has an EQ instance. While this works, it's rather unsatisfying. Yeah. Alternatively, we can write a closed type family, which will fold the TS, so these, it will fold those into a big constraint stating each element has an EQ. So we can do it in one. That's what it's saying. But what we need to do is create a new type family. So we've got a type. Yeah. Do that. And this one will... And then we end up making it even smaller. So that's of the type... yes, like that. So list of types. And then that whole thing is of the type constraint. So we've dealt with constraint before, so that's okay. And then we can do all EQs of a promoted constructor of list, or empty, is going to return us a unit, which is a bit freaky, but... And the next bit I can explain actually, because I got stuck on this next bit as to why there is a tuple. Why is it a tuple? It doesn't make any sense. You know, you'd think it'd return, but it's in the same... When you look at... Because generally when you use these constraints, you know, you'd have your types. You'd have my ducky. My ducky. You know, so you'd have whatever your constraint is. So you'd have like show A. Oh, sorry, show A and EQ A. And then blah 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 blah. Yep. Oh, actually, let's just do some of that. I don't know. What would be of an A? Whatever. Yeah, whatever it would be. Doesn't really matter. So this would be your types, and it obviously one of them would take an A. And you see how when you do your constraints, you comma separate them. But that's what it's to do with up here. Apparently. Yeah, that's what I was told. So, as all EQs in our first example of a non-trivial closed type family, we should spend some time analysing it. All EQ performs type level pattern matching on a list of types determining whether or not it is empty. So number one, if it is empty, an empty line, we simply return the unit constraint. And it explains here. Note that because the kind signature on all EQ, Haskell interprets this as constraint rather than a unit type. Yeah, so that returns constraint. So that returns, ultimately that's that right there. Yeah, but you can't just return constraint, can you? Because I guess it converts it to that. So that'd be a bit weird. Yeah. Yeah, and then below it goes all a bit mental. Oh, I'm missing one here, aren't I? T. That makes sense? Yeah. But you can see where the recursion is happening. So that's the first part. And then the second part, we sort of like decompose it. We get the head and then the rest. So we can do EQ on the head, and then we can pass all EQ to TS. And it just keeps going around until it, it'll go around, keep returning, blah, 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 and until here. So that's what it's saying when it's saying it's doing the fold. It's folding over them. So, however, hold on. So, constraint rather than the unit. However, if TS is a promoted, I didn't even need to keep going. Read on. Promoted list cons. So, promoted data constructor. So, which list cons is. We instead construct a constraint tuple at 2. You'll notice that all EQ is defined inductively, so it will eventually find an empty list and terminate. But using the kind command in GHT, we'll see what the type family expands to. Okay, let's have a look then. So we'll load that. What should we load? We're loading... Is it finding anything? Why not? Why don't you find... CH0. There we go. What is it? Okay. Oh, okay. It's just a warning. So we want to do kind. I bet it won't work. Maybe it will. Let's try it. So this is all type level stuff. So we're doing yes, like that, and then here we want an int and a bool, and then hopefully perhaps you intended data kinds. Yeah, I thought this would happen. That's fine. Why is this? This is because we need to set a bunch of stuff. So all of these. Though that's annoying. I've definitely... Oh, hold on though. Yeah, it's only this part we need. Let's have a look. Error. Type inball. Perhaps you intended to use data kinds. No, I didn't. Maybe it needs... let's have a look. Set X data kinds X D. It's not even fine. Oh, whatever. But that's what it's meant to return. I'm not going to look into it. Oh, here it is. Let's try again. Oh. Yeah, thanks, Leo. You're on fire. I forgot it was a dash. So I'm guessing it might be this first and foremost. And then do you think... I reckon it would be the other one also, mightn't it? Don't do that. What? Look at this! Some flags have not been recognised. That's weird, isn't it? What do you mean some flags? Okay. Well, it's happy now. And then let's find it. There we go. Yeah, so it was that. Which one it was, we don't know. I guess data kinds. Or constraint kinds. Be one of them too. Yeah, so we see the result, which is the same as up here. So that's cool. I'm assuming that it'd be that one because it kind of mentions there's nothing specific about EQ or EQ specific to EQ about all EQ. Instead, it can be generalized into a fold over any constraint C. I don't know what C is referring to. Any constraint C. Do we see a C in here? No, certainly not a C. Whatever. We need X constraint kinds in order to talk about polymorphic constraints. So now we're like stepping it up. This is the next one. So we do type. We do a type family all. Okay. And that's a C. Oh, this C. There it is. So that's a function of a type to a constraint. Okay. Yeah, this is a bit long-winded, this one. Well, not long-winded, but I'll try and explain it in the best possible. And then we're setting, so now that this is the type of everything, so all of that is a constraint. Where? Now we get all C. Ah, so now we're just dealing with a C, which seems okay. And that returns us, again, that returns us unit, especially when you want to do it like that. Okay, just do that. It'd be way quicker to just delete it and start again. But what can you do? And T cons onto TS. So we're still at, like, we're doing a type family right now. So we're there. And here we can do C, T, all C, TS. I think, okay, let's have a look. So I think, oh, here we go. It also takes me at least 2 tries all the time to get this right. Oh my goodness, yeah. Well, this is now my first. It's only my 3rd try. But if anything like my memory, just forget it, don't you? Okay. Okay. So we're here. Let's try and explain what's going on, shall we? Oh, the set syntax. Yeah. Yeah, it takes me. I always forget you have to have that. It's just annoying that it's yeah, it's mind bending, definitely. So you have it like that there, and then when you use it up here, you have it like different. And then sometimes they have like dashes between them, but then up here they haven't got dashes. Why don't they just make them all the same? Anyway, not something I can change. So we've got this. So a type family of all takes 2 values. One of them is a C, which is a function which takes a type and returns a constraint. And then we've got a TS, which is just a list of types. So if you look at like there, it's very similar, isn't it? Well, this part is almost like all EQ, except we take this extra bit here, which is a function from type to constraint. So if we do all C and then we've got an empty list, much like this one, but technically I guess we could do that, couldn't we? But all right. Yeah, we can do that. Now it's not happy. It tells us after. So it ignores this C. Otherwise, if we use all C and then we deconstruct the T cons with the TS. So that's cool. So then we see, because we know that, does it tell us? Let's have a look, actually. Can we do type holes here? Wildcards not allowed. That would be amazing, wouldn't it? If we have wildcards in there. Why is it? You'd think you'd have wildcards in here. So we'd know what like T and TS were. Okay, well, let's, whoops. Actually, it gives us a fault here. What's this saying then? Oh, so it can give us the kinds. Okay, yeah, so look, that's telling us that it's a list of type. TS is a list of type. And then T is just going to be a type. Yeah. Because a star is type, isn't it? Cool. So that's what it's saying. So we can see this expects a type, returns us a constraint. The C does. So we're passing that in. And then we're passing the rest to keep doing its stuff. So ultimately we'll end up with like one of these that is whatever the length of the list is, and then the final one will just be a unit, or it'll be a constraint is what it gets converted to. So with all, we can now write our EQ instance more directly. So now we can have them both. So you see how before we had to write two of them, because it wouldn't, because from this implementation up here, you know what, I might just comment this stuff out here. There, yeah, so then we can sort of see it a bit better. So from that implementation, we had to write two of them to deal with lists. Yeah, but then we wrote a different type of implementation, which is like that, but then we can make that even better by making it like that. It doesn't, why is it, hold on, so it's a polymorphic constraint, so what's the difference? What does it say? So a list cons we instead construct, you'll notice that all EQ is defined inductively. What's it mean when it says inductively? Like inductive is like to from particular instances. Instincts rather than inductive reasoning marks her approach to life. Okay. So it will eventually find an empty list and terminate. So that's fine, that works. But what's different? There is nothing specific to EQ about all EQ. So there's nothing specific. Okay. Instead, it can be generalized into a fold over a constraint C. We will need constraint kind in order to talk about the polymorphic constraints. Yeah, I'm not sure why. I guess we have this part, which is different from that. And then you're using it to go from type to constraint. But here, what's T here? That's the same. It's the same stuff. So I'm not sure why. Does that mean that it doesn't necessarily just work? Yeah, hold on. Oh, I'm not seeing the fact that that's constraint to EQ, isn't it? Oh, I get you. So this is the ability, this C is the ability not to just use EQ, but to also use any type constraint. So like there, like ORD, EQ, and shown. I think that's what we're going to do and pass it with this C. So if we look at how EQ, we implement that with EQ. I think that's right. Yeah. So if we look, EQ is our C. There's our C. That's EQ. Yeah. And then we have the TS. So all this is happening in the type constraint over here. Okay, so we've got all EQ and a TS. And our TS is obviously going to be this part. Cool. And now we want to do the constraint against EQ. So we've got EQ H list of TS. Okay, that makes sense. Where H nil, oh, that's equal to H nil, which is true. Okay, that makes sense. And then here is A cons onto A's is equal to B. Oh, it's over here. Cons onto B's. That equals, let's line them up. There we go. That equals A is equal to B, and what? Oh, A's is equal to B's. Okay, which is very much the same. All EQs TS. Cool. And now we need to do ORD and show. So I've got a feeling from memory. Yes, we'll do ORD TS. Oh, let me look at ORD. Yes. Oh, no, that's fine. All ORD TS, fat arrow, and we'll have ord hlist ts. I think this is where it might be wrong. So look, compare. No, yes, yes. Compare h nil with h nil, and that will return eq. Okay. Attempt to fill hole. What's this going to do? Less than. No, don't do that. It's definitely not less than. It's EQ. Ah, here we go. So we do have some sort of an error up here. Could not deduce all EQ TS. Oh. Hold on. So I've got a feeling that... I've got a feeling you have to do all... yeah, there we go. Because it says it can't find the EQ. There we go. Yeah, that got me stuck last time. So there. So could not deduce. So I guess to do an order, you have to know the equality. That's what it's saying. So then at this point, it's saying, well, I don't have an all EQ of that. So then you have to pass it along in our constraints. Yeah, there we go. So then we do compare A's and B. Whoops, B's. Yeah, there we go. So we'll do all this again, basically. I mean, it should be identical now. A, B, and then in this one, compare. Whoops. A's and B's. A. Yeah, it is interesting, but I couldn't. Let me see if I've still got it. I think I had it on a discussion somewhere. I basically asked about it, and then I was told you probably need to do more to get it. Where was it? No. No. Here we go. This one. So I kind of like asked. Yeah, you can see this was where I struggled with it. It's about constraint. So exact issue. So we did that. And here. And then this is where I was like, well, I didn't really, for some reason, I didn't spot the all EQs. I just assumed I was doing, I don't know, I just didn't spot superclasses. So what it's saying is, oh, someone has a good mobile. It's not very intuitive. Okay. Don't know what that means. Okay. Have a particular question. Yeah. Okay. Constraint is a kind of constraint. Oh, and then I think I just reeled off about constraints. So I never really got an answer as to why it needs both. Hold on. Yeah, so we kind of, well, show. Yeah, so we got all the so we understood the constraint stuff, but I didn't. And then have I skipped chapter 2? Well, now I've been working through them all on stream. Actually, didn't skip it at all. Yeah, so basically I'll just start to go back. So, oh, hold on. All EQs, but that really awkward way to write a signature. Yeah, I don't know. No. Oh, and then there's some new feature that's come out, so you can write it differently apparently. So this stuff is apparently obsolete of sorts. So you can write it differently. Didn't really understand. And then some whatever's going on there. Didn't really know. Yeah. So basically, don't know. Was what's the outcome of that? Oh, what I could do is I could ask, couldn't I? Right, we'll set a note. Why? Also, shouldn't the compiler complain because there is more than one instance for EQ and ORD? No, I see what you mean. What you mean? No, because I think this one's using all EQs and this one's using all. Is that what you mean? Oh, you mean within there and it's using it again there? Is that what you mean? I think that's what you mean. Yeah. Yeah, I don't know. But maybe here they're only constraints. Yeah, because it's constraining there. But then why? How can that have two constraints? Why does ORD need two constraints? Shall we have a look at how the... Maybe how the ORD is done against list? Like the instance of ORDs for list? Maybe we'll see it there. Oh, you meant lines? Oh, I know you meant line 90 and line 60. But I think you're right about all EQs. Yeah, sorry. From 60 to 90. I think that's what you're saying. Yeah, they're different. They're just after the actual EQ itself. So we're making we're doing it against this H list, but in this scenario, we're doing it against that type family. Well, we're not even using that one. Look, I'll be happy. We're literally just using those two. Whoops. So that one is a all EQ, but I guess this. Oh, look at that! I've even just spelled that wrong, and it's not complaining. Hold on here. I've got a feeling that something isn't right. Yeah, there is an error. Oh, is it up here? What have I killed? Maybe that's what you were on about. Hello? What's it saying? Overlapping. Yeah, well, yeah, you're totally right. Why wasn't it complaining? Well, it was. Just the compiler didn't tell me. You're right. Honestly, you're sharp. Sharp, that is. That. To the point. So let's reload. That was a good spot. You're like the new Haskell language server, Leo. You can do it. you can just sit in the background. You know when you get the joke of like there's like little mice working behind the scenes, sort of like making things electric go. That's you behind the Haskell language server. I'm not implying that you're a mouse though. Don't worry. Their mice are pretty damn clever, poor little fuckers. I guess I have the advantage of not sitting in front of the camera. Well, I don't mind. Yeah, this is the other thing, isn't it? Most people are kind of afraid of looking stupid, aren't they? I don't really mind. It doesn't matter. The thing is everyone's struggling. Oh, yeah. Is it like that? Is it like a quiz show? No, I don't even get that. I just don't get it. I'll stare at TV and I'll be like, what are they on about? I don't know. Don't have a clue. Where are we? Hold on. So we did... I've lost trail. So we've done this one? No, hold on. What have we done? Have we just skipped a load of stuff? So we did all EQs. Oh, okay. So we're just doing our own. So we've done ORD. And then show is just going to be like the same, really. We just need to sort out this bit for show. But I don't think it's not going to take both, is it? It's just going to be like one. But I'd like to know why it needs... Oh, well, we're going to check it out, weren't we? Let's go have a look. We're going to have a look at instance... Oh, go away, go away. Go away. Show was a and whoops, like that equals. So it should just be. Oh no, we just literally we'll just copy that. Yeah, there were overlapping things, weren't there? That was a good spot. And then we could just copy this. Because then we're just having it all in one. Okay, so hopefully this should be happy now. And then we'll wait. No, it's not happy. Why are you not happy? Oh, it's still some more. Oh, of course, because I only commented out there. Okay. Right. Everybody's happy now. Hopefully. Why is it broken again? And what we'll do is we'll look at the board. That's what we're going to do, aren't we? So let's go to Hoogle. Let's do odd. Or do we need to... Let's look at... Oh, look! But that's weird. Class EQA. So that's why. Because look, it's got a constraint of EQA on odd. So we were missing that. I think that's what it is, isn't it? Oh, hold on. Maybe I'll zoom in a little bit. We've gone too far. There it is. Yeah, look. Odd is class EQ. Odd's got a constraint of EQA. So you need an EQ to be able to work out an order of something. There we go. We learn something new every day. That's one for the TV quiz. Unfortunately, yeah, I guess, well, unless you know that, it's probably not too clear. Should make a note. Actually, let's make a note by going like this. If I ever check these again. We don't need Y. So, constraint of all EQ. Yeah, I think that's right, isn't it? It seems it, because if you've got a class of, if the class has a constraint of EQ, then it means that, what was it? Line 95. Oh, to have it straight up here. Well, I think if you look at like all the other constraints that we have, so just for the EQ, you have to have something on the left saying that TS is going to be a VQ. But because when we look at the type class of the A, so order of A, so there's our A, well, this needs to have EQ, but when we look at it, we're only giving it odd. So it's just going, well, you're just having odd. So then that's why if we then get rid of it, it then says, well, you're missing an EQ. To get an odd, we also need an EQ constraint. No, you see? That's what I thought. You'd think it'd just be all odd, but no. Because we need to give it an extra constraint of EQ. Yeah, like that. And then it's happy. Weird, isn't it? But I think that's right. It's because of, if you look at a type class, there's that EQ there, and it's just popped up. And I guess then if we look at odd, is there constraints? Here we go. What do we want it on? Is there like some form of a... what would be a good one? Well, we need like a list. Which, yeah, this is the problem, because I guess it's not exposed to us, is it? Order of... Oh, but it's the inner... And it's not even like the value, it's the inner value of the list, isn't it, that we're doing the order on. It's not the actual bit on the outside, we're creating our own. So yeah, so it's even inside of that. Let's have a look then. Let's have a look at just... which one to make? Should we go order of char, for example? No, char's going to be bad. Date.char, ord. Where's ord? There. Oh no, go back. Where were we? Ord of... Let's do a double. Oh my goodness. Why have you gone all the way here? What? Okay, let's just have a... It's a bit weird, isn't it? So if we go there... Oh, so we can't even look at it. it's like straight on the business. Yeah, there's no source. There's literally no source. Ah, weird, isn't it? It's another built-in jobby. Yeah. Oh no, source here though. Okay. Let's just do it on int. So look what the source is. Could be anywhere. Word, wicked. Oh, not interesting. It must be a type level thing. Because yeah, well that's for int 8 and I guess, I don't know where. So look, ord, what should we do? Int, it's going to be more in one place. There we go, int's in C, int 64. Yeah. So it's literally, it doesn't even have like compare, does it? It's doing them explicitly. And then whatever these take, yeah, that takes 2 ints and a bool. Okay, well, we'll just have to figure that's why it's doing it for some reason. All EQs is because of the class. The class. Where is it there? Because of the class constraint. Maybe. I've got a feeling like it's correct. My feelings aren't always right. What's going on here? Convert to use. Oh, it's probably telling me, why haven't you finished it? You said you'd do it about 5 weeks ago. Oh, not core I'm unsure about. Oh, you got it the wrong way around. I'll reply. I got well into it and then I just didn't carry it on. Right, anyway, chapters. What's the time? Should we start chapter 6? We could do, couldn't we? Hold on. Oh, it's a different one. This is rank. Yeah, let's just do it anyway. I can make a start on it and then. Oh, excuse me. Oh, I think I'm struggling on Sunday evenings, and it's also like 6:30 here, so shouldn't do it this time. Get hungry. What am I doing? I've totally forgotten how you do it. Create. C. Yeah, it's C. Create directory. 0. So this time I've got to remember to name it properly. So I had that problem last time, didn't I? Create file. Subchapter 06. We'll have it HS. And then we've got a module of chap 06. Chapter 06. Where save. Let's just do some. Yeah, let's go down here. Let's go the Cabal file. Like that. That'll change. We'll do some of this. Yeah, that'll rebuild. See, it's doing its little wiggly thing. So, introduction. Rank n types. Sometimes Haskell's default notion of polymorphism simply isn't polymorphic enough. Well, you'd think the use of the word would be, wouldn't you? It's polymorphism isn't polymorphic enough. Just wants more. To demonstrate, consider a contrived function which takes the ID. Hold on. Have we not done this? No, we haven't. But we did this. No, we haven't at all. Okay, this is what I was reading. Okay, this is where I'm going to get stuck. So it's probably good I don't do it all. Because next time I'll do a call for help. Please come join my stream and help me. It'll be a slightly different format. To demonstrate, consider a contrived function that takes ID A as an argument and applies it to the number 5, our first attempt might look like this. So we can have apply to 5. So this is not going to be happy. I was trying to type without putting my hand in front of my face when I yawned. It didn't work. Got caught up. Okay, so this is going to fail. You'd hope. Okay, maybe it's not. What? Please reload. Please fail. You'd think it'd fail? Okay, that's better. I was like, well, it's fixed. Don't know what you're trying to teach us. What's the error it's saying? No instance for num. Yeah. Okay. It's basically... Well, it's going to explain to us. So the reasoning here is that because ID has a type A to A, apply 5 should have the type A to A and returns an int. Unfortunately, Haskell disagrees with us when we tried to compile this. Yep. Couldn't match an over int. So we can't apply F to 5 because, as the error hopefully points out, A is not an int. Yeah, so A is like, at that point A is nothing. It could be any type. And I guess just passing it to 5 doesn't give it a constraint. Recall that under normal circumstances, the caller of the polymorphic function is responsible for choosing the concrete type those variable gets. So it's whoever... Oh, okay. So from here, it's not, you know, it doesn't know what the A is. It's only when you... my think. It's always my funk, but whatever. So we could say... We'd have to give it... Okay, so let's just say it returns int. And then we'd have my func. And then we don't care about the value, so we could do apply to 5. Is it then happy? Are things then hunky-dory? You'd think not, but maybe. Yeah, okay. So that's what it's referring to anyway. So from here, you can set it. So, yes. The caller of polymorphic function is responsible for choosing which concrete types those variables get. The signature A to int promises that apply to 5 will happily take any function which returns the same types as it takes. We want apply to 5 to only be able to take ID. Yeah, so anything that does A to A. So that type tool is essentially saying what A to A is. A to A, so it can be ID, breakpoint, lazy, inline, you know, like all these different. There's loads of them, obviously. So just A to A is not, you know, it's still a little bit too like. Well, you could be anything, my friend. You could be anything. Okay. So that's responsible. Take a function which returns the same types it takes. We wanted apply 5 to only able to take ID as a parameter, but instead we've written a function when if it compiled, which it doesn't, would happily take an endomorphism. So endomorphism is functions which take and return the same type. For example, not is an endomorphism because it just takes an A and returns an A. Show at string is an endomorphism. ID or endomorphism, but something like words isn't because it's a string to a list of string. You probably can't read that down there. What I should have done is a bit of this. Might have helped. Yeah, so it's just saying not shows an endomorphism. ID is an endomorphism, but word isn't because you can see it returns a list of string, not just a string. So it'd have to be something that returns exactly the same type. So in that scenario, it makes sense. We're there. Because the choice of A is at the mercy of the caller, Haskell has no choice but to reject the above definition of apply to 5. it would be a type error to try and apply to 5 to not, for example. Ah, fix that one. Where is it? At the end or the beginning of this? It's a bit right. It's the end of that one. Stream offer. Okay, I'll have to splice the end of that one. It's a big right at the end, which is horrible. Okay, so that makes sense. So it's just saying, well, no, we only really we can't pass not, even though technically that'd work. It wouldn't work there because we've got a 5 inside. Okay, oh, yawning again. Oh, which is like helping, isn't it? Okay, it would type error to apply to 5 to not, for example. Yep. And so we come to inevitable conclusion that, as is so often the case, the compiler is right. Yeah. And we, at least our type, is wrong. The type of apply to 5 simply doesn't have enough polymorphism, but why not? And what can we do about it? So the discrepancy comes from the quirk of Haskell's syntax. By default, I'm sure we've looked at this. When did... Maybe not. I don't know. Maybe I was... Yeah, anyway. By default, the language will automatically quantify our variables, meaning that the type signature A to A is really syntactic sugar for all A to A. So it's, yeah. By enabling a rank n types, we can write these desugared types explicitly, comparing. Okay, so let's add some of that. Let's add some of that, and we'll go like that. First we'll do this, and then we'll try and work out what it's saying. So rank tank. I wish it would give me predictive text on there. That'd be nice. I mean, I guess it's that fails, that passes. That's the only way I can tell. Take something away, put it on, it's fine. So at that point we can do that, and then we can do, for this, we can do for all A. A to int, okay, and then what we can do, ID, show an ID down here. Surely it'll complain though, but we'll see. A to A, ID, A equals A, okay, that makes sense, except we can't use that ID. Yeah, of course it's ambiguous, is it? I don't know. Oh, hold on. Okay, so it's still failing, but that's fine. We expected that. So recall that this is what it's desugared into. Ultimately, that's when it's failing, it's because we've got this. So it's doing for all the A's, they have to be the same. Int. Okay. Recall that we intended to give the type ID for the first parameter of applied to 5. However, due to Haskell's implicit quantification of type variables, we were led astray in our attempts. Okay, this explains why. What do you mean we were led? Okay, I guess we were led astray somehow. I might have not read that properly. For first parameter of apply. So recall that we intended to give the type ID. Yeah, I don't quite get why that is, but never mind. We were led astray by our attempts. This explains why apply to 5 above didn't compile. Does it? I don't know if that sentence explains it. Maybe this bit, due to Haskell implicit quantification of a type variable. What is an implicit? an implicit quantification. I don't know. Haskell's implicit quantification. Okay, well, we'll ask that. What is Haskell implicit quantification? Oh look, putting a comment above it makes it work. Yeah, it won't do that. Okay, the solution is easy. We simply need to move the for all A part inside the parentheses. I can't really spot it. Is it oh, no. I don't know. But it needs to be inside of there. Oh, okay, okay, I think I get it. So if we look again, we'll put that there. So I guess the for all, so what's the word? Implicit quantification. Is that because it's quantifying that within this function? And here we're trying to pass this, whatever's quantified inside this function. So when it's on the outside, really we want it to pass this along. I mean, that's like a wild guess. If I look at the patterns and it looks like it. I mean, it's happy now. And here, I guess we could just do ID. No, we can't. Oh, yes. No. Oh, hold on. So would this work? Oh, okay, hold on. Good. Damn it. Oh. Okay. I'm just restarting things. Just to see what's going on. I'm certainly not at all... Okay. Right. So we need to move it in. Okay, in this chapter we will dive into what rank n types are and what their more interesting uses can do for us. Is this just like a little warm up? It kind of feels like it's an explanation, but then you get sort of thrown this bit. I don't know what. Don't really know what that is. That's extential, implicit parameters, universal quantification. Whew. I need some implicit knowledge, I'll tell you that. Zoom in. Implicit knowledge, no. Who knows? I'll ask. I'll ask on Slack, just not now. I mean, I guess we can move on without it, because I guess it's going to explain a little bit. I think this is like the chapter that just, I was like, yeah, right, I'm done for. Because that's the problem. I'd like to have a good, at least a fairly good understanding. This is going to find it, is it? No. So we need to close that. We need to do this. Like that? Yeah, here we go. No, it's loading. So we're reloading the REPL. And we're going to load... find it? Yeah, load Ch. There, it's found it now. So I guess we should be able to use apply to 5 ID. Should return as 5. Okay, well that works. And let's hope. So the rank n types is best thought of as making polymorphism first class. Okay. It allows us to introduce polymorphism anywhere a type is allowed, rather than only on top level key bindings. So that says, and let bound expressions. Oh, and let bound expressions through the polymorphism is usually invisible to the everyday Haskell programmer. Though this polymorphs, so anything in the let. Okay. While relaxing this restriction is obviously a good thing, it's not without its sharp edges. In general, type inference is undecidable in the presence of a higher rank polymorphism. Number 3. There's too many like, look here, look there. Theoretically, it's possible to infer types for rank 2 polymorphism, but at time writing, GHC doesn't. So the rank stuff was like the level of functions that you're passing to it, isn't it? So if you've got like a function, you tend not to go above 2 ranks from memory. So code that doesn't interact with such things need not worry, but higher rank polymorphism always requires an explicit type signature. But what is exactly is a rank? Okay, that's a bit weird, isn't it? It kind of like throws you onto here, tells you, oh, there's a rank of 2, but what is a rank? Okay, I guess we'll get told. In type theory lingo, the rank of a function is the depth, there we go, of its polymorphism. A function that has no polymorphic parameter is a rank 0. Okay. Right, so something that's just like this, that'd be a rank 0. Because, but this would be a rank 1, I guess. Be my guess. Let's have a look. However, it's not all. Oh, however, most, if not all, polymorphic functions you're familiar with, like const, a, b, a, or head, a list of a to a, etc., are rank 1. Okay, the function apply5 above is rank 2 because its f parameter is itself is rank 1. Okay, so this is a to int, I guess, is rank 1, and a to a is rank 1, so it's rank 2. Because its f parameter itself, yeah, in principle there's no limit to how high ranks a function can be, but in practice nobody seems to have gone above rank 3. Let's do it. Let's go. I'm going to go to 4. If you're not sure, turn it up to 11. And for good reason. Higher ranked function quickly become unfathomable. Rather than explicitly counting ranks, we usually call any function above rank 1 to be rank n, or higher rank. Yeah. The intuition behind higher rank types is that they are functions which take callbacks. So they are functions that take callbacks. Okay, so what's the callback in ID? Let's keep going. That takes callback. The rank of a function is how often control gets handed off. Oh, okay. A rank 2 function will call a polymorphic function for you, while a rank 3 function will run a callback which itself runs a callback. Okay, because callbacks are used to transfer control from a called function back to its calling context, there's a sort of a seesaw thing going on. For example, consider an arbitrary chosen rank 2 function, foo. Let's do it. What's foo doing? Let's have a little look at foo. Oh, foo has a dot for 1, so that's wrong. As the caller of foo, we are responsible for determining the instantiation of R. Oh my goodness. Look at, I mean, yeah, I can remember why now. So foo, I guess, takes an F, and then I guess we can just do, yeah, we can just do that for now. That's fine. What would be that? Foo's, yeah, okay. As a caller of foo, we are responsible for determining the instantiation of R. So of whatever, oh no, of R, okay. Yes, I think. How? As a caller of foo, yeah, stop reading the same thing. However, the implementation of foo gets to choose what type A is. So inside we get to choose what A is. Oh no. Oh. The implementation of foo gets what type A. However, the implementation of foo gets to choose what type A is. The callback you give it must work for whatever choice of A it makes. This is exactly why apply5 works. Recall its definition. Oh, this one, I'm telling you. This is definitely going type level business now, aren't we? I don't think it's probably not complex, but I guess I'm not fully understanding what it's going on about. Yeah, maybe. I think it's probably a lot of new terminology, which is throwing me a bit. But if we keep reading, maybe we'll get it. So applied to 5, we gathered that if we put the for all inside here, then the f will work. Notice that implementation to 5 is what calls f. Okay, so this inside of here is what calls f. So I guess, and then at that point f. So if we were to say call this boo, for example, and then we'll just we'll get rid of this for now. Okay. So that's yes. If we go, oh no, we can't just derp. What am I saying? Okay, so there we're calling f, and f is whatever we pass on. So at that point we're calling it. So we can imagine f is boo. Okay. Notice that the f, because f is of rank 1 here, applied to 5 can instantiate it to it at int. Okay, so then we're saying that a, okay, so we're instantiating this a into an int because we've passed it that straight away. Oh, okay, so I guess because when we see that, we're ultimately it's this. Okay, and then to determine what this a is going to be, we pass it along, and then that constrains all these a to int. Okay, that kind of makes sense. Compare it with our broken implementation. Yes, applied to 5, where the for all is like on the outside. Here, f is rank 0 because it is no longer polymorphic. Ah, I get you. So whoever, I'm with you. So wherever the for all it sits in, its caller gets to dictate what this a is going to be. So from here we're saying well, it's going to be a 5. So that's why if we have it on the inside, that makes sense. Okay. So say, yeah, so that's why if we have it on there, then the caller of apply to 5 gets to determine what the a is, not this function. Yeah. So it's kind of like passing this for all. So if we look at here, so what it's saying here is the caller of foo is going to be able to tell us what the r is. So much like we're f to 5, but then from inside of foo, we're able to dictate what. No, hold on. F. Yes. So whoever's going to use, yeah, okay, we can do it. Whoever's going to, the caller of foo, so whoever uses foo, will get to dictate what the r is. But then this function, we get to dictate it from within foo because of the for all that lives here. So if we imagine that, you know, we had another function that literally, let's have a look. So we, you know, if we had another function that was poop, and its type was that. Yeah, so if poop, its type was that, and then from within here, we'd literally just call, we could just call f. And we'd just pass it on, but let's just pretend, which is probably not that good. No, because we need to be able to dictate what the r is somehow. I don't know. That's probably, that's kind of like leaving it a little bit confusing. Oh, it's not able to tell us what. Yeah, okay. Okay, is it okay? So that'd be an int. So then we're then able to tell. There's the f. Okay, I'm going to go back to my logic that I had before I confused myself. But ideally, it's saying that whoever's calling F, that gets to, so it's us here, we're able to call F. And here we're dictating that F, this A is going to be of int. And we're passing it along. And then now it knows that that's int to int. Once we call that, that's int to int. Saying that we pass in bool. But then, yeah, is that what it's saying? Oh my god, I had it and then I've lost it. So the caller and then, yeah, because we're calling that. And this one is from within. Yes, okay. So here we set our A from within here. But here we're basically saying, well, we're going to pass that along from there, and then it's set from within here because when we called. So imagine we're essentially calling that, then that 5 is making that an int, and then they're both int to int. Okay, so that's why the for all can be on the outside. But once you've got it on the inside, we're basically saying, okay, we'll pass. You know, if you had it on the outside, then we're saying that whoever calls apply 5, yes. So for all A, okay, so imagine it's that way, then this A value, whatever type it's going to be, gets passed on from the caller. So if someone calls apply 5, then whatever they set it up with, that will be the A. Okay, that makes sense. So, or we could have, as an example, we can do this. Oh, hello. We could do like a B and a B, okay? And then whoever calls apply to 5, that'd be like that. And then that'd be a bow, for example, okay? And whatever value you pass it to apply 5, so the caller would then set what the B is for apply 5. But from here, we're basically saying, no, I just want to get that value from the caller rather than, yeah, so I want to get that value from within here rather from the other way around. Okay, it makes sense in my head, but I'm finding it difficult to explain it. If it's too confusing for you too, let me know, because I think I get it. Maybe it'll explain if we keep reading. I think it makes sense. So from the caller or from within there, and that's a function, so it's from within here. Yeah, it's a tough one to explain. Let's see what it says. Here, F is of rank 0 because it is no longer polymorphic. Okay. Right, because it hasn't got we're just doing A to A. Okay. Is no longer the caller of apply to 5 has already instantiated the A. Oh, okay. They're like two totally different A's, aren't they? Okay. Right. So it's saying that when it's whoever's the caller is going to be able to set that A. So whoever's the caller of foo is going to be able to set the R. Whoever's the caller of poop is going to be able to set the A. But then in this instance, whoever's the caller can do that, but our F, we want the value that we pass it, the 5, to then be passed along to whatever for here. Then that become the value, rather than constantly. Yeah, so we want to pass it along, even though we're a caller, but we want to be explicit about that with using this for all A. I guess. I think so. There's probably like really smart ways of explaining it, but that's how it feels. By the time apply to 5 gets, okay, so the caller of apply to 5 has already instantiated the A by the time apply to 5 gets access to it. Yes. So the caller of apply to 5, so whoever's calling that, has already instantiated A. Yeah, so we can no longer, here we're trying to make F use this, and that becomes the A of whatever F is. But in reality, when we do a for all A, you know, whatever we pass on to 5 will give it that instantiate what the f is. Yeah, so because we've got a 5 here, it's not going to work. But if that was just literally to be an f, I think that's what it is. Oh, it makes sense in my head, but yeah, I'm not explaining. Let's have a look what it says. So we know gets access to it, and as such, it's an error to apply it to 5. So hold on. As already instantiated, A, by the time apply 5 gets access to it, and as such, it's an error to apply it to 5. Okay, so you can, if you don't have the for all inside of here, for example, well, first and foremost is, okay, let's just do A. Then it's going to be an error because, you know, it's whoever calls apply to 5. But then if you're only passing on the function, at no point are you, you know, so if we were to create a function that literally just did called apply to 5, and then we passed it boo, for example, which is what it expects. We'll get rid of the b because that just makes it a little bit like that. Get rid of this. Yeah, so here we're still not, you know, we still haven't instantiated what the a is by doing that, so it can't be a int. You know, we've just got this random a to a, which hasn't got any sort of constraint. So if we put the for all inside, then at that point we're able to pass it along to boo, you know, pass it along to here, rather than try and instantiate it inside. Then we're allowed to do it from within here. But because it's on the outside, it's saying, well, I want to instantiate it. Let's just do that. I want to instantiate it here. But we're not passing any values of a here, are we? So it can't be right. You can't just, you know, it's at the call site where the for alls are going to get instantiated, but we've got no way of instantiating anything at this point. So for it to be valid, we have to stick this for all inside of here. And then we can just pass that along. And then from within here, that's going to pass that into here, and ultimately that 5, the int, will be passed into here. And that's why it needs to be on the inside. Yeah. Take deep breath. What's the time? Okay, I might finish all this after that mind bender. Okay, so by the time apply gets access to it, and as such, it's an error to apply it to 5. We have no guarantee that the caller decided a is int. Yeah, so here, how can we say that that's int? There's no way. We're just passing it a function, aren't we? There's no int to be seen. So that doesn't get passed along. Yeah, that makes sense. By pushing up the rank of apply to 5, we can delay who gets to decide the type A. We move it from being the caller's choice to being a callee's choice. There we go. Yeah, so instead of like, yeah, so from with here, we'd still be the caller of F. But we want to, yeah, because the issue arises because we're passing along a function. And that's why it's a rank 1. We're passing around just a function that's expecting values. But because it's so polymorphic, it's hard for it to dictate what it's going to be. So if we leave it to just that, then that's where the issue arises. So we're able to pass that along, which is literally that. We still don't know at this point. We still haven't told what this for all is going to be. But if we to put the for all left here, then we're still not able. But to turn it round, then we have to have it inside, and then it's able to pass that function into here and then dictate that. Yeah, that makes sense, because without doing that, F5, it can't do it because you haven't got the ability to pass it back to call it here. But when you put it on inside the A to A, then you can. We move it from being the caller's choice to the callee's choice. Even higher yet ranks also work in this fashion. The caller of the function and the implementation seesaw between who is responsible for instantiating the polymorphism type. We will look more deeply at these sorts of functions later. Well, it can go even deeper. What is the time? It's like 7. The nitty gritty details. So maybe we stop here for today. It's probably a little bit of a short one. But what I'll do is I'm going to do that. Yeah, I'm going to do that. And then at least we know where we're at. And I'll probably do a better one tomorrow. I should probably read ahead because, yeah, look, here we go. This is why I was like, So what is the rank? Okay, you can kind of work out the ranks. And then it asks you to work out ranks, but then this is when it gets a bit, here we go. Provide a functor instance for cont. Okay, that doesn't provide an applicative for cont, doesn't seem too bad. A monad, and I think later on it does ask you to do like a monad transformer. Yeah, there's also a monad transfer version of cont. Implement it. Yeah, so that's going to get a bit, now we're getting a bit heavy. Oh well, I think that's okay. That's not bad for a day. There it is. But thank you for coming and joining. I'll carry on with this, or I'll do some more basic stuff next time. We'll work it out. But yeah, I think that'd be a good, guess it'll be good to go through this repo whilst things are hot on. So maybe we can even sidetrack a little bit, because we could definitely do this one, the GADTs, because that's like fresh in the mind. That's only recently been done, and we could probably get up to there. So maybe in the next video we'll see how far we can get with these. Let's have a look. Is that some exercises? Yeah, stuff it. We'll do that. We'll have a go. Okay, I'll try and remember on my you know, I set up things, no schedule, no whatever, what I'm going to do, just YOLO. Right, on that note, on that bombshell, I like to say, there it is. Cool, well thanks for joining, and hopefully see y'all soon. See you later.